Join with computer audio. How many football games you have left?
3.
3.
Let's do 3.
All right, there you go.
Found out canceling.
All right, here we go. Just not enough people or what?
All the JV family.
Just
Yeah. Most of the kids are juniors and seniors that play JV.
in the Saint, like, they're probably not gonna win a game this year.
Okay.
Tennessee.
Let's be honest, it's been a rough year. So, all right, here we go. Due Tuesday, 4/6/2021. Okay, so you already took your test. That should already be turned in. This Ed puzzle should no, there's no well.
Let me make sure I turn my word.
Okay, fair enough. I can buy that.
You don't always slack on that.
Well, you could have just stopped a little earlier in the sentence, but that's fine. The point is, Mr. Moore is going to have like, here's how much pity right there.
No.
There you go.
No.
Now, half-life and doubling time. If I'm not mistaken, we did not go over these, so we'll go over these together. All right, before we get started, actually, you know what? No, I take it back. How many of you are juniors? Crap.
All right, juniors, get out.
Oh, wait, that's not tomorrow. That's next week, isn't it?
Yeah.
Never mind, then I guarantee you what we're going to do. Okay, here's what we're going to do. See all these delta maths? Canceled. All right, canceled. Because we need to make sure you are ready for, you need to make sure you're ready for trig. Well, you need to make sure for SAT that you know sine, cosine, tangent, yada, yada, yada. So you also need to know the special triangles, 45, 45, 90, 30, 60, 90. So all of those things you have to be familiar with. Now, okay.
Back to last year, what are you talking?
That was last year.
Yeah, clicker, hero.
Okay,
That was just.
here we go. We'll do the ambiguous case later. So white nose. All right, first things first. You should already be aware of the two special triangles. The two special triangles are 45, 45, 90 and 30, 60, 90. You should already be aware of those. I am not betting on that. Then you have basic trigonometry. So things like SOHCAHTOA, CHOSHAHCAL. You need to know those. And then you need to be able to do all of those. Okay. And then trig inverses. All right, well, we're going to move this down here because if I need the absolute minimum beforehand, okay. Okay. We'll go over that in class. Okay. Cool. That's where we'll start then. All right, basic trig. It's going to be a bit of a crash course, but that's okay. Okay, here we go. Close Chromebooks. Dale, you can turn those in later tonight.
What?
Any missing work that you have?
No, it's just one.
Okay, great. So the point is, what else? Here we go. So, ha, toa. Show, sha, how. Okay then. Well, there would be absolutely zero singing here today. Now, no. Okay. Do not do this in any voices because that makes it not appropriate. Okay. Don't, yeah, just don't. Now, there is a lady that I used to work with that used to dress up as a person of Native American descent, as an indigenous people, full on feather and whatever, and had made up this entire story about Sokotoa.
That's my normal voice.
Well, again, still sounds inappropriate. And this one right here might be, again, just don't. I'm warning you. Thank you. Now, what this stands for is sine of an angle is made out of opposite over hypotenuse. Now, let's talk about what that means. In a right triangle, you have a right angle. That makes sense, doesn't it? And you have a hypotenuse. Okay, a hypotenuse is the longest side of a right triangle. It is always across from the right angle. Why is it always across from the right angle? Because if there's 180 degrees available in a triangle and there's a 90-degree angle in there, it is literally impossible for any other angle to be bigger. Does that make sense? So hypotenuse, always across from the 90. Now, let's talk about this, angle A and angle B. If that's angle A and that's angle B, we're going to call this side over here the opposite side. Why would we call that the opposite side of angle B? Because it's on the opposite side. That's a good call. Okay. This one we're going to call the adjacent side. Now, for example, white sits adjacent to Corning. What does that mean? Next to. That's all. Next to. Now you say, well, the hypotenuse is next to B as well. Yeah, but the hypotenuse is the hypotenuse. It's like I ain't gonna be adjacent on the hypotenuse. Yo. So adjacent is right next to the angle. In fact, it's part of this. Here's the challenge though. If I'm talking about angle A, now where's the opposite side?
It just flips and reverses around.
Yeah, this is opposite angle A. So it's adjacent to B, but it's opposite of A because it's literally on the opposite side. Which makes this side what? Adjacent to A, but it's still opposite on B. Okay, so when we talk about sine of an angle opposite over hypotenuse, if I have sine of A, let's give it some numbers here. 4, 3, 5. Here we go. What is the sine of A? 3 over, because it's opposite over hypotenuse. However, if I have sine of B, it's 4 over 5, because opposite is opposite of B, but the hypotenuse is still 5. Okay, now let's do cosine of A. What is the cosine made out of? Well, ca is A and H, which is probably made out of and the A, the adjacent side. Do we agree?
Yeah.
So what side is adjacent to A? What is the hypotenuse of A? There you go. Now let's do tan. Tan of A. Tan is toe of, which means what? Opposite over adjacent. So that's going to be
3/4.
3/4. Now let's fill in. I need cosine of A or cosine of B, and I need tan of B. Okay, what's cosine of B?
Cosine of B would be 3/5.
Adjacent over hypotenuse, 3/5. Tangent is
4/3.
4/3. Very good. All right, that's all this is.
So you're not trying to solve, you just put in like sine and then 4/5 to solve it and do a calculator.
No, absolutely not. Because here's the thing. Sine of an angle is 3/5. You don't take the sine of 3/5. It's the sine of the angle is 3/5. And we'll come back to that in just a minute, okay? Now, let's go over here. Trosha Cal. This was 3, 4, no, it's backwards, isn't it? This was A, this was B, that was fine. Everybody agree with that? Now, this is the one you're probably not familiar with. Cosecant, CSC, of A. What is cosecant made out of? Hypotenuse over opposite. Do we agree? Where is A? Right here. Where is cosecant? Hypotenuse, which is over opposite. Okay. Then you have secant of A. So that'd be SEC of A. Secant of A. Secant is made of. Okay, so where's hypotenuse of A? Adjacent of A. And then cotangent of A, which is COTA. Cotangent is adjacent over opposite. So what is adjacent to A? 4. What's opposite of A? 3. 4/3. All right. Now let's do a comparison. Okay, what's the pattern between the two?
Oh, it's the opposites for the bottom one.
Ah. They just switch, don't they? So, in this case, notice my picture is progressively getting worse. All right. So, Toa, in fact, I had to very carefully look at my video and make sure that I did not use the voice when presenting it. Well, here's the problem. There's a guy that I've met a couple times that has about 250,000 subscribers called Flipping Physics. And he actually had to do kind of an apology video for his deal here, because again, my videos have been up for about 7 years. His have been up for about 10. And he's far more popular because his videos are like amazeballs. But at any rate, yeah. There are things that are appropriate or that happen in classrooms that now that y'all can text your mommy, if I'm mean to you right now, like we can't do that. Or you can just, you can record us. And again, things like that you say to your friends are things you say to your friends, but you take them out of context, they become less than appropriate. And let's also be honest. Can we all just agree that we can learn to be better people as time goes on?
Our generation.
It's like
Now-
back in my day, the teacher hates the kids with a
Okay, Mr. Ward, just a reminder, we are recording.
Yep.
Okay.
It's on the internet.
Yep. Now, sine of B, cosine of B, tangent of B. Here we go. Sine B, cosine of B, tangent of B. Here we go.
Would be 4/5.
4/5.
Cosine of B would be 3/5.
3/5.
Tangent is 4/3.
4/3. Now, let's go over here. Let's go to cosecant of B, secant of B, and cotangent of B. So here we go. What do you got?
5/4.
5/4. 5/3.
3/4.
3/4. Okay. So here's the thing. If this is like the MCU, this is the multiverse. Okay? It's like the same, but not quite. It's like when they replace an actor in a series with another actor, and nobody ever mentions it. You're like, what? It's kind of the same, Aunt Viv, but it ain't. Okay, so that's the idea here. Sine, cosine, tangent, cosecant, secant, cotangent. I guarantee that is SAT. Okay, 100% guarantee that is SAT. Okay, so you need to have that memorized. You need to be able to do exactly what we've been doing. And almost inevitably, one of those questions will be, do sine of B, then they'll turn around and do sine of A. Because why? They want you to make sure that you understand that the sides flip. Does that make sense? Okay, let's go back over here. 90 and 45. What is that angle over there? How do you know it's 45? Because it's literally all that's left. And they're always in a relationship of 1, 1, root 2. Okay. Over here, we also have a 30, 60, 90. 30, 60, 90. Up here is always 2, 1, and the square root of 3. Okay. This also is almost guaranteed to be on the SAT. Now, in this case, what if we have this much bigger 30, 60, 90 triangle? And this is 7. How big is that? Good. How did you figure that out? Oh, you doubled it. Okay. So in this case, 1 goes with 7, 2 goes with 14. Great. What's this one? Not square root of 21. What is that one? Here's 7 root 3. Here's how you come up with that. Can you say 1 goes with root 3 as 7 goes with what? Can you say that? What do you do to solve that?
You have to finally simplify down to just root 3.
Or just simplify.
I do my more complicated ways.
Yeah, you do. 7 root 3. Are you good there? Okay, that's it. Let's go over here. 6 root 2. How big is x? 6. How big is y?
6.
Good, excellent. Okay. What if that's 12? How big is x?
1, 4, 4.
No. Here we go. Let's do it. You ready? 12 goes with x. Everybody agree with that? As what, White? Okay, well, it's time to focus then. Am I going to use this triangle or this triangle? Left or right?
Left.
Mr. White.
Left is the right. Yeah, because that's that triangle.
Oh, because it's 45, 45, 9. Oh, okay. So we're going to use this one. So I said the hypotenuse to this leg. So what would you compare up here? Want you to follow my finger, you ready? Ready?
Yeah.
Watch it. Okay. Hypotenuse to the leg. Where do I put my finger up here? Where did I start a minute ago? Good, so I'm gonna say hypotenuse to the leg. So I'm gonna say what? Okay, Mr. White, let's take a look here, buddy. This is the problem with staring, but not actually focusing. Do we have a hypotenuse on the leg?
Yes.
So if I'm gonna set a proportion, I'm probably gonna go from hypotenuse to leg to hypotenuse to leg, because I can only compare like things. Do you agree with me? Cool, so if I went 12 to X, I'm gonna go up here to my stock standard. I'm gonna say, where's my hypotenuse?
Well, it's the 12 on the bottom.
Well, up here, what's the hypotenuse?
2.
Root 2. Cool. Where's the leg up here? Good. So now what am I gonna do to solve that gap? You betcha. So I got root 2 times x equals 12. What do I do to get x by itself, guys?
You square and then divide by 2. Because you want to get rid of square root, so you can. Wait.
Well, I mean.
That would give you x squared.
Yeah.
I don't know, I think x, I had x on the.
Oh,
I didn't know.
you, double.
Divide by root.
How do I get rid of something that's multiplied?
You divide it.
I'm gonna go with divide.
Yeah.
Lord almighty.
There you go.
6.
Eric reading.
X equals now. Eric, I like your enthusiasm and you're so wrong.
I know.
Because
I noticed.
12 over root 2 is not 6. How come?
Root 2 is not 2.
Root 2 is not 2, is it? How do you get rid of the square root that's in the bottom? How do I deal with that guy? I have to do what? Yeah. So I'm going to multiply top and bottom by root 2 over root 2. What is root 2 times root 2? 2. Got 12 times root 2 all over 2. Boop, 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 6. 6 root 2. That is your answer. Now, ladies and gentlemen, here's the thing. SOHCAHTOA should have already had it. 45, 45, 9, 36, I should already have it. It's not your fault necessarily that you may or may not have had it. However, you take a test that is going to help determine your college entrance abilities, or even if it doesn't determine your college entrance, because my college doesn't take my SAT number. True. But then as soon as you show up at their door, what do they put in front of you? A test for math placement, correct? So if they look at your SAT score and they go, oh dear God, what is a 300 doing here? The first thing they're going to do is put you in a math class where you don't get college credit for math. You're like, well, that's okay, I'm going to be, what are you going into?
I want to be a psychiatrist.
Yeah, okay, not a lot of math there, right? But I guarantee he has to take statistics.
Yeah.
Okay, and it's not just basic statistics like Math 170. Okay, what are you going into, White?
Conservation.
Conservation, so he wants to be the conpo, right? Now, maybe not the police, just conservation in general. Okay, but you still have to take, it's going to have a lot of business classes, and there's going to be a lot of biology, correct? Okay, so he's also going to be doing statistics because we're monitoring fish populations and native plant invasive species populations. We're graphing them over time based on the inputs that we put. Okay, because I know I do this in conservation. And again, you're going to have to do basically a business calculus course. Okay, and so you don't want to start in Math 098, which is where kids that can't do math start, and pay for a class that you don't even get credit for and work your way up to the stuff that actually applies for your degrees. You going back to the farm, or you going into something else?
Oh, probably take over the thing.
Right, but it's business, so will you go get an ag business degree?
I'm not spending 100 grand. I'll go to community college.
Okay, but even community college, I can tell you where you start. Hi, I'm the 098 teacher. All right, so you would not be the first person. You would not be the first person to walk out of my classroom only to go to college and walk right back into my classroom. So the point is, ladies and gentlemen, you might focus a little bit over the next 5 or 7 days to make sure that if there are, say, 2 questions out of 60 on the SAT math test, right? If there are 2 questions that have to do with trig, what's the difference between you getting a 47 and you getting a 49 because you picked up 2 points? The answer here is a whole bunch of SAT score. Okay? Picking up 2 questions really makes a huge difference in that SAT score. All right? So, highly recommend that you memorize the following. SOHCAHTOA, because CHOSHA-CAL probably not going to be on it. I'm just letting you know. You also have to memorize how to do that guy there and this guy here. Okay? Because if you have 2 of those questions and say just 1 of these questions, there you go. That's 3. That's 1/6. That's 5% of the test, right? So you get the idea here, guys. This stuff that we're doing right now is huge. Now, let's go over here, Corin, and let's talk about what this stuff means, okay? What I have here is if this is my angle, if I have the sine of that angle, it's opposite over hypotenuse. If I started this right here, let's say that this is the boom of a crane, okay? Boom of a crane, and so we're here, or the hi-ho, whatever you want to talk about. You raise it up, correct? What if this has to touch the ground to grab whatever is sitting on the ground, okay? What happens
It has to shrink.
to this opposite side as it goes down? The opposite side has to shrink. You have to pull in the cable, correct? The higher you go, what do you have to do?
Raise it.
Let out the cable, all right? So this opposite side is always in some sort of ratio to this hypotenuse. And what doesn't change? The hypotenuse, because it's the steel arm. Does that make sense, guys?
Yes.
So that's why sine is a relationship between opposite, this side over here, and this hypotenuse. Now, if you've ever worked with cranes, or you worked with hose, or you worked with buckets or scoops, whatever, okay, you have different lift ratings based on where your lift is, okay? If I have this adjacent side, all right, I can lift a whole lot more weight here than I can lift here. How come?
The way levers work.
Yes, the way levers work, that is 100% correct. So if you're at a particular angle, I can only lift, say, 500 pounds here. But if I'm here, I can do a 750 lift, no problem. Okay? Becomes pretty important. Becomes pretty important. Here, wait a minute, we'll make it John Deere, we'll put a bunch of plastic crap in that. All right, so,
Lift hay bale up.
correct.
Tractor tip.
Right, see, this is pretty good in here, this is not good out there. All right, so the whole point of this is, it's just a relationship that you have to know. And that relationship is going to change based on the angle. So, with that in mind, if this is my angle, call it alpha, okay? You can call it theta, whatever you want. Put your phone away. Why do we always have a right triangle here in the case of our cranes or whatever? Because for all practical purposes, gravity works downwards 90 degrees to the ground, okay? In this case, let's say I have a 32-degree angle right here. All right, sine of 32, plug it into your calculator. So I don't have a calculator. You have a phone? You can grab your phone now if you don't have a calculator. Go to the calculator, and if you're part of the Apple board, how do you get to sine, cosine, and tangent on a phone? You turn it sideways.
Sine of 32 is 0.529991.
Okay, whoa. 0.52 what?
9919.
Okay, blah, 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 blah. Okay. Here's the deal. What does that say?
Numbers.
It says that the opposite side is about 53% of what? Of the hypotenuse. So it's a portion of whatever your hypotenuse was. Okay? So in the case of our crane, however long your leg is, your cable has to be about 50% of the leg distance for the down portion. Okay? Now, if I wanted to do cosine of 32, somebody give me cosine of 32.
0.848048049.
Okay. Now, let's actually draw this at 32 degrees. At 32 degrees would be less than 45. Do you agree?
Yes.
So let's bring our loop down. So here's our down, and here's our over. Does it make sense that this is going to be about 53% of the arm compared to almost 85% of the length of the arm? Does that make sense, folks? Okay, so corner, let's go back to our statement. If I had sine of A was 3/5, okay, what we're saying is whatever 60% of the hypotenuse is, that's the angle that it goes with. Does that make sense?
Yeah, I think I was misremembering one Pearson thing.
That's fine. So the point is, these are ratios of heights and distances, heights and widths. So heights and widths, sines and cosines. Now tangents, why do we care about tangents? Well, let's say we don't know this dimension. Okay, let's say we don't know that dimension. Here we go. Somebody comes to the Horton farm, says, we want to put up a cell tower. We're going to pay y'all a lease fee for some land, right? Except, there you go. Except for, we ain't going to use a cell tower like this. Those are expensive. We're going to use the skinny type, and we're going to have to use an outrigger. Okay, we're going to have to use down cables. Say, well, we want to put a 50-foot tower up, right? Well, what dimension are we going to need if we have a 50-degree angle? What kind of clearance zone are they going to have to lease around that tower? Well, they're going to need to know, if I know an angle that I can put it at, I know a height here, I need to know the adjacent side. I don't frankly care how much cable I use, because cable's cheap. The expensive part is a big old tower and leasing the ground from the farmer. So what I care about is this guy here, opposite and adjacent. Do we get it? Okay, opposite and adjacent. And why do they have to lease that much ground? Yeah, because a tractor ain't gonna fit under the cable. Okay, so you're basically wasting land. Why is it that they've gone to these giant poles for the windmills? That's it, because they lease far less land versus if you've seen the old windmills that are like the little bitty windmills, it makes a big difference on how much land is down at the bottom. Okay, so SOHCAHTOA, Choshikau. Okay, with that, let's go over to Delta Math. And edit assignments. And Algebra 2, trigonometry. Okay, so here we go. This is exactly what we were talking about a little bit ago with Mr. White. I assume we need to zoom in a little bit. Now, obviously, which of my two special triangles am I going to use? What should be across from the 90? 2. What should be across from the 30? What should be across from the 60? That's the part you have to memorize. That has to be in your brain. Now, can I set up a proportion fairly easily? What do you want to do to get x? 1 over root 3, because he says this goes with what? This root 3 here. I didn't know if you were going sideways. So if I went that way, here to here, what am I going to do? Root 3 over x. Are those two like fractions? Okay, by the way, the reason I asked him which way he was going, could he have said this little short side to that little short side? And then what would he have done? Root 3 to x. Now, it looks the same only because they both happen to be root 3, correct? But as long as you can compare any two equal pairs, you're good. By the way, the answer to this would be 3. Because root 3 times root 3 is? Good. All right, what am I going to do here? What kind of triangle am I going to use? Okay, what goes here? Good. How are you going to set it up? Oh, wait a minute. I suck. Root 2 over 1. Does everybody agree? Is everybody okay with that?
Yep.
Any questions on this? If you don't know these two special triangles, what are you?
A dummy.
You're screwed. All right.
I was like, wait a second. I know what
Good job. It's an inclined plane wrapped around the cylinder.
that is. All on it.
Here we go. Now, what do I do here? Good. Well, what should I probably start by doing? I'm going to probably draw a triangle. What kind of triangle? Probably KLM. I don't know anything about it. I just know it's K. Well, I know it's KLM. What do I know goes on the 90? So, does it matter where K and L go?
Yeah.
Does not. The only one that matters is that dude is 90, correct? So what's LK? What's KM? What's ML? Okay, at this point, do I know all three sides?
Yeah.
What is the cosine of L? Well, cosine of L, what's cosine made out of? Or y?
Adjacent hypotenuse, so 24 over 25.
So, TOA What is it? 24 over 25. There it is. And what is your answer? 24 over 25. Unless it says round to the nearest tenth or something. In what case would you do? Take 24 divided by 25. Again, is that what we did right there? Was that challenging? That's very quick. All right, what do we got? C to E. What's the most important angle? E is, I'm going to put C here and D here. Could you put them backwards and still come up with the same answer? Yes, because opposite and adjacent will simply change based on where you put it. Where's DC? Snyder cut. All right, CE. And ED. Never mind. All right, and sine of D. What is sine made of? Opposite over hypotenuse. Everybody agree. Where's opposite of D? White. Opposite of D. Perfect. Over D. Over what? 89, right? Now, what does it say though? So what am I going to do? Okay, so it's going to be about 0.4 blah, 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 right? Okay, there you go. All right. Cosine of A. What is it? 60 over 61. Do we agree? Sine of B. B. 45 over 53. They're switching it on you. Didn't I say they'd do that? Cosine A.
15 over 39.
Sine of B. Tangent of A. 27 over 36. Okay, get the idea, guys. How much work should this be? Good, except for the fact that you have to draw the triangles and label them. But it's okay because you have like 10,000 seconds. All right. Yep, 10,000. All right. Using a triangle to find a side. Ooh. How do I find X? Well, here's my question. Let me know. What's that? What side is that compared to 57? What's this? Okay, so probably what you're going to use. I'm going to say you're going to use sine, right? Because is that opposite and hypotenuse? Sine of what? Equals so the 65 over x. Does everybody agree? At this point, should you be able to solve for x? Because what is sine of 57?
8.386708.
Okay, good. All right. Usually 4 decimals is pretty good. All right. So what do you do to solve this, by the way, since x is in the bottom? You have 2 options. One, could I multiply both sides by x? And then divide both sides by the decimal. Can I do that? Okay. Here's an easier way. Now what do? And solve. Can everybody do that? Okay. And, oh, I should have solved that probably. Oh, well. New problem. Cool. How do I find x? What do I know? I know adjacent and hypotenuse. So what's adjacent and hypotenuse? Cosine of equals x over. All right, which would be the easiest way to do this one? Multiply by 2, wouldn't it? Because the x is on top. What is the cosine of 41?
0.75479.
Thank you. All right, x over 2. Now what am I going to do? Multiply by 2. And what do you get?
1.50941916.
Okay, and does 1.5 make sense down there? It does. Okay, can we do that? Now, this says exact value. You need to watch this on the SAT. Because if it says round to the nearest whatever versus exact, what does exact mean? Which fractions or decimals? Fractions. All decimals are rounded, which means they're inaccurate. So what am I going to do? What is the cosine of A? 9/41, and I leave it. What if I have this? And I want cosine of A. How do I find cosine of A? Okay, but that's not an exact value. No, do you see a 30 anywhere in here or a 60 anywhere in here? Okay, here's my question.
Oh, you got solve for X.
Do you know two sides of a right triangle? So what can I do?
Oh, do the ratio.
Okay, so what do I do? Dale, tell me how to find X.
Oh.
Well, I'm aware, but that's why I want you to focus. How do I put this information in the Pythagorean theorem?
4 to the second.
Perfect.
6 to the second.
Ooh,
Oh,
X to the second. How come?
X.
2 legs, correct? And 6 squared. Does everybody agree with that? So I got 16 plus x squared equals 36, correct? So x squared equals 20. How do I deal with that guy if I want exact? Square root it. Okay, what's the square root of 20?
You're just gonna leave it as
It's like, wait a minute, I'm waiting for Lieutenant Dan to blow his legs off. What is it? Oh, this is a little cheap. All right, 2, 10, 2, 5, pair of 2's, 2 root 5. So what's the cosine of A? If here's 2 root 5 right down there. What's cosine of A? 2 root 5 over 6. How come that is exact? Is there any rounding in any way? Okay. Oh, cotangents. Shows your cow. All right, that's fine. We'll skip it. Ah, you are the worst. All right, identifying all 6 trig ratios. Here you're doing sine, here you're doing tangent, here you're doing cosecant, here you're doing cotangent. What's the only thing you have to remember? The 2 phrases that paces, right? Ah, here's a fun one. I know, I'm excited too. So it says, given secant is blah, 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 angle in quadrant 1. Here's my question. Where's quadrant 1? Okay, we finally got it out of him. Top right, there's quadrant 1. Does everybody agree? All right, so we're going to drop an altitude. Does that make a triangle? Good. The angle is always at the origin. So what's secant made out of? I don't look. Hypotenuse over adjacent. Do we agree? So we know that much. Does everybody agree with that? Right now, could I find the cosine? Yeah, 7 over 6 root 65, correct? Could I find the tangent or the sine though? I cannot, because what don't I know? I don't know the opposite side. How do I find that? Or the Pythagorean? Yeah, sure. So we got 7 squared plus x squared equals square root of 65 squared. Now, for some reason, this right here blows kids' minds. Not entirely sure why. Alan, what is the square root of 65 squared? I want you to listen to the words that are coming out of my mouth. What's the square root of 65 but squared? It's just 65. How come? Because square root and square are reverses. Does that make sense? Now, you see that and you go, oh, derp, right? But I'm telling you, most kids, they get very confused. They're like, oh my gosh, they get very upset. It's not a big deal. So I got 49 plus x squared equals 65. What do I do now?
Subtract 49 over.
I am. So I got x squared equals 16. What's x equal? 4. If I know that this is 4, could you tell me the sign now? The tangent, the cotangent, the cosecant. Well, good, because that was good. All right, so you can tell me based on the quadratic formula. Not quadratic formula, excuse me. Pythagorean theorem. Pythagorean. Do you go to Taco Bell and ask for a burrito supreme? All right, now, in this case,
I got a panda and asked for a panda.
nice.
Never give me one.
I know. All right. It's because the Chinese doesn't let them out of the government, out of the country. No, seriously, they don't. Pandas are not allowed out of the country. All right, now, how do I do a triangle like this? What do I know? Okay, how many people can plot a point? If I just said, hey, can everybody plot a point on the graph, you'll be like, yeah. Well, fine, do it. What do you do?
Right, 24 down 7.
Over 24. Then what?
Down 7.
Cool. Does that make a triangle?
It does.
Oh, okay. So then all I gotta do is use Pythagorean theorem to find the third side, correct? And where's the angle? At the
0.
origin, at the zeros. So could you find sine, cosine, or tangent of this now? Yeah. Guys, all of these different types I'm giving you, because any of these could be SAT problems. Okay? And frankly, you'll be in better shape than Heidel's class at this point, because they're not going to get here. So, which is fine. We just happen to be close. And, oop, what do I do here? How do I find, I reverse the process. Very good. Technically, I inverse the process, for sure. What is this?
The opposite.
What's this? Good. So what am I going to use if I have opposite and adjacent?
Tangent.
Oh. Tangent of x, and this corner is a good place to end because it'll be right at your question. 3.4 over, good, somebody find me that.
.453 repeating.
Okay, do we agree with that? What do I do to get x by itself?
Divide by tangent.
Ooh. Can I divide by square root?
No.
Can I multiply by add? No. So can I divide by tangent?
No.
Yes.
No. What's the reverse of tangent? Look at your tangent button on your calculator. No. Literally on the button.
Tan -1.
Tan inverse. It undoes tan. So the reversing of tan, so hit second tan, then 0.453333. What do you get?
24.37.
So approximately 24 degrees. Now, by the way, that doesn't look like 24, does it? But does it make sense? Because does this look about half as big as that? So it's not drawn to scale. So what I want you to get, and I know this has been a lot and it's been fast. I get it. Okay. But it's okay because you got to have all this. So basic trig inverses. I'm going to move these back up here. What's this one? Homework. Nope. I think you can handle those homework problems. By the way, how fast can we do this? What's X? What kind of triangle is it?
The 45, 45, 90.
Good. So if this is 5, how big's this? Oh, 5. Yeah, because it's the same, isn't it? And what's this? Root 2 times 5. 5 root 2. Done. Okay, over here. If this is 4 root 3, how big is just the shorty side? 4. And how big is the big side? Double it. 8. Okay, so here's the thing. This, and this, and this. Yeah. Do you're the worst. Does anybody ever tell you you're the worst? Because I just did. Okay, I'm just double checking. We need to make sure that you are well aware. Okay, look at the due date. Okay, when is that?
Next week.
It's literally a week from today, correct? Now, this, don't put stuff away until I'm done. This, I don't know about smiting. I don't know the name of smiting. But is there a lot here?
Yeah.
Yes. Is it, first of all, we've gone through it. Second of all, is it literally 8 days from today? Okay. Why am I giving you all this? Get ready for SAT. All right. So get these accomplished. Do not do the normal where you're like, oh, just do it the day before, or maybe 2 days after. Because the only person you hurt is yourself in this case, literally. Okay?